One of these questions in 8.5, so we're starting with multiplying, and for the first 6, I don't care if you do box method or if you do FOIL. So if you're deciding you want to do FOIL and you're more comfortable with that, go for it. But I did put the boxes on here so that you could use them in case you prefer box method. And I will show box method because most of you in the past have enjoyed using box method more than FOIL. So for the first one, you still do the same thing you did in the warm-up. So we have 2 square root of 3, then 1 and square root of 5 go here. Multiply just like you did before. So 1 times 2, good. 2 times the square root of 5 is just 2 square root 5. 1 times the square root of 3 is just 1 square root of 3. You don't have to write the 1. I'll put it there just so you have it for now, but you don't have to write it. And then, what is square root of 5 times square root of 3? Square root of 15, yes. So remember back to 8.3, when you're multiplying together, if they have the same index, you just multiply the radicands together. Now, the next step when you're using this is to combine like terms. But this one does not have any like terms. I'm going to write out each of these. And that's going to end up being your final answer because the radicals, they all have the same index, but not one of them have the same radicand. So the number underneath the radical isn't the same. Square root of 15, I can't simplify that any further because 5 times 3, they're both prime numbers. That's not going to simplify any further. So this question, this is as far as you go. This is your final answer so that you have that.
That's simple.
That's all you can do for that question.
So the next one has freaking
Well, we're going to go down first.
Oh, okay.
Yeah.
That was 2.
Nope, we're not going to go across. We're going to go down. So number 2, I have 2 binomials. And before you even do this problem, what do you know? So one of them is negative and the other one is positive, but they're the same numbers. And this is something called a conjugate. Conjugate. We're using that term again when we start talking binary numbers, which is coming up within the next 2 sections. It's in fact the last section, 8.7. So we have 8.6 and 8.7 is imaginary. So these are conjugates, and all that means is one's a positive, one's a negative, everything else is the same. And when you end up with conjugates, 2 things will cancel off, whereas the 2 other boxes will stay where they are. So let's figure this out just like we did before. So we have 4 negative root 5. 4 positive root 5. Good, 16. I would put the negative out in front, so negative 4 root 5. Good, 4 root 5. Negative square root of 25. Okay, now I'm going to combine like terms here, so we have 16. Now, one of these is a negative, the other one's a positive. So what's going to happen there? They're going to, I don't have to add these together, they're just going to cancel off right away. And then I have minus, because there's a negative sign right here. Now, what's the square root of 25? 5. Okay? So 16 minus 5 is 11. So that would be my final answer for that one. So when you have a complex conjugate, yes, but when you just have a plain conjugate, 2 things are going to cancel off because you're going to get the same answer, but opposite signs. So you can cancel them off, you'll be left with...
For, like, whenever you do 16 minus 5, you're not going to put the 5 inside the square root?
Nope. Because the square root of 25 is just plain 5.
Okay.
Yeah. Now, 3, I think I screwed up when I created this problem. I think I needed a radical somewhere, but let's just work with it. We're not going to need to use the box method. Let's simplify what's underneath the radical. So 13 minus 2 is 11. So I have the square root squared. And what do you know about that? It's just 11 because the radical will cancel each other off. So this answer is just 11 as well. Unfortunately, I don't make the test. Okay, number 4. Now, Molly, you were concerned before because number 4 has an index of 3. That's not going to change anything. So I'm going to still write it in my box method. It is a conjugate. That's good. So you can put conjugate there. Cubed root of 7 for negative cubed root of 7. Multiply 4. So what's going to go in that first block? Good, 16. Second block. Perfect. I like the way you said that too. 4 cubed root of 7. Then negative 4 cubed root of 7. Good. And then finally, we'll have negative cubed root of, yes, good, 49. So, same concept. We have conjugates here. The boxes that are on a diagonal are going to cancel off because one's a positive and one's a negative, so I'm going to cancel those off right away. So I'll have 16 negative, so I have to put a minus sign, cubed root of 49. Now, usually you're going to want to simplify that, but how can you split up 49? What two numbers multiply together to be 49? 7 and 7, and I need a group of 3 in order to simplify it. That's not going to happen, so I just have to leave it like that as my answer because nothing else can happen. Okay, let's go on to number 5. This is really complicated. It looks a little more scary because of all the radicals. That's not going to change anything. Again, these are conjugates, so you can write that. You know something's going to cancel off. And then start filling in the sides of your box. So square root of x, square root of y, square root of x, negative square root of y. So square root of x times x is square root of x squared. We are going to simplify it after. But if you want to simplify it already, that's fine. Then we have square root of xy. Yep, negative square root of xy. And then negative square root of y squared. Since we have conjugates, the diagonals cancel off. So I'll have the square root of x squared minus the square root of y squared. And like some of you already noticed, what is the square root of x squared? X. And the square root of y squared is y. So it's x minus y, and that's my final answer. And then number 6, do the same thing. So you can work ahead if you can. These are conjugates again. How do you what?
I was going to say, how do you get the negative square y squared, but it's because of those two.
Right. Okay, so we have 49 square root of x squared. So we have 49, and I can just call that x because we already know the square root of x squared is x. My conjugates make it so that my diagonals cancel. And then we have minus square root of y squared is just y. So you'll get your answer 49x minus y. So we already did multiplication. Now we're moving on to division, which is usually not quite as fun or easy as multiplication. But let me explain what rationalizing the denominator is. So in the math world, we don't want radicals in the denominator. That's a huge no-no. We're not allowed to have them. So in order to get rid of the radical in the denominator, I need to multiply by a form of 1, so I don't change the problem, but so that I can get the radical out of the denominator. And to do that, all you're going to do, and I would like you to write this at the top, you're multiplying the numerator by the radical in the denominator. So what that means is it doesn't matter if there's more than just a radical in the denominator. That's what I'm taking. So in number 7, I'm taking the square root of 11 and multiplying it by both the numerator and denominator. So in number 7, multiply by the square root of 11 in the numerator and in the denominator. What that's going to do is I'm multiplying by 1 because the square root of 11 over the square root of 11 is just 1. I'm going to change the value of the problem. But now what's going to happen? Well, in the denominator, square root of 11. The square root of 121 I'm going to write first, but yes, that's going to give me 11. So that's going to be my denominator, just plain 11. And then 5 root 11, yeah, it's just 5 root 11. We consider that simplifying it, and it's only simplifying it because I'm getting the radical out of the denominator, and that's your goal. Number 8 has an extra radical in the numerator. It's not really going to change anything. It's not going to make it much more complicated either. We just have to do the same thing we did in number 7. So in number 8, you're multiplying the top and the bottom, so numerator and denominator, by the square root of 5. So I'll get 5 square root of 30, because 5 times 6 is 30, over the square root of 25. Now 30 I can't really simplify. I'll have 6 and 5, and that's not going to leave it like that. So 5 square root of 30. But what's the square root of 25? 5, right. So we have 5 root 30 over 5. Now what's 5 divided by 5? 1. So this cancels, and my final answer is just the square root of 30. I want you to practice 9 and 10. So give 9 and 10 a shot, and then we will go over it and move on to the next problem.